When we talked about diffusion in class, we looked at two different demos that we did during class, and we looked at how those demos taught us different things about diffusion. So we did two things. First, we did popcorn, and the second demo that we did involved food coloring or dye in water. We're going to look at each of them individually. So the popcorn demo started out by everyone sitting at their seats, and I walked in through the door and stood at the middle and the front of the room with a bag of popcorn. And I said, raise your hand when you smell the popcorn. I opened the bag, and then gradually people through the room started raising their hands. It took some time, but eventually everybody in the class raised their hands, starting from the front and moving towards the back. Then I presented all the students with the task of to create a storyboard of what happened during the popcorn demo. And this is generally what most students came up with. So all of the smell particles started here at the front. They slowly moved throughout the room, and then they spread farther, and then they spread even farther until the end when the smell particles were spread all throughout the room. I presented students with a couple of different questions. First, we talked about in order for the particles to move from the front of the room to the back, what must the particles do? And we said the particles must move. When we're drawing particle diagrams, we show motion by drawing what we call whooshies. So those are these little lines behind the different particles. So you have to think in your head of a comic book. What do you notice when, or what do you see in a comic book or a comic strip if someone or something is moving fast? You see long lines behind them. So when we draw fast-moving particles, we draw long whooshies or lines behind our particles. With our slow particles, we draw short little lines or short whooshies behind the particles to show that they're moving slowly. We also noted that it took time for the particles to move through the room, and I asked why. We eventually came to the conclusion that our room is filled with air particles, so it takes time for those smell particles to make their way moving through all of the air particles until they got to the back of the room. So they had to work their way through the air particles, working through collisions with other smell particles, collisions with the air particles, and eventually move to the back of the room. In the second demo, I had two large beakers. One was full of ice water that didn't have any ice in it, but it was very cold. And I had another beaker full of warm water. And at the same time, I put one drop of food coloring in each beaker. And then we watched what happened. As we saw the dye move through the water, I had students whiteboard what they observed. And this is generally what we saw. First we had to show that there were water particles. Those are the X's in all of the beakers because we have water. We also have to show something for the dye. So in this case, in the cold one, I drew blue circles, and in the hot one, I drew red circles. We talked about in the hot beaker, the water particles are moving quickly because they're warm, and hot particles move faster than cold particles. In the cold beaker, our water particles are moving more slowly because they're cold. They don't move as quickly. When we drop the dyes in, the dyes are initially moving at the same rate because they're liquids, they're at room temperature. But the cold dye slows down because it loses, we didn't talk about specifically what it loses, but we know it loses speed somehow. So those particles move slowly, and they really only diffuse right down the middle of the beaker. The red ones, however, as soon as we dropped the red dye in, those particles started moving quickly because they're in a hot environment. Therefore, both the water and the dye particles are moving quickly, and the dye spread very rapidly throughout the whole beaker. All of this hinges on the idea that hot particles move faster than cold particles. So to kind of summarize the idea of diffusion, diffusion is the net movement of a substance. Whether it's a gas, whether it's a liquid, we looked at both today. It's really just the movement of a substance. And there are two things that kind of influence diffusion. The main one that we looked at was temperature. Again, hot particles move faster than cold particles, so if you want something to diffuse more quickly, you need to heat it up. We also have to pay attention to the medium. Gases are going to diffuse a little bit differently than liquids simply because they're different states of matter, and they move differently. Gases move faster than liquids. Things moving through gases are going to move differently than things moving through liquids. The main influence on diffusion that we're going to pay attention to is the temperature. And that if we warm things up, things will diffuse faster because the particles are moving faster.